Thank you very much for your time. Uh, Now I'm going to present our research which has titled XNOR-YOLO, the high precision of the ball and goal detecting on the Barelang-FC robot soccer. Here is our outline. In the beginning, we will introduce our work and the hardware design, and we will explain the XNOR-YOLO method, and we will show our experimental result, and lastly we will conclude and show the future work. Our motivation is the YOLO was the most powerful object detection method in the nowadays, and which able to predict and detect the object with high precision in a real-time application. And the YOLO method has a lot of conventional layer to predict, detect the object. Sometimes make a need the very high computation even in GPU and affected the object detection speed. So the YOLO is need a huge computing cost for work well. That's why we developing high precision and fast object detection method for the vision system and Barelang humanoid robot. And here is our related work. First, our related work is Susanto did his object detection for his robot for detecting the ball and goal pole that they are they use YOLO, or it's actually a sort of you only look once method. It's one nowadays is the fastest method to detect object through the deep learning. And here is because they apply it to the robot. They used NVIDIA Jetson TX1 and Linux OS as a operating system. Our second related work is Mohammed. That in this work they propose two efficiency variants of convolutional neural network by adding the binary weight network, so-called XNOR network, to change the weight and input layer into binary value. So when the both weight and input have binary value, the network is very efficient in terms of memory and computing, being very accurate natural image classification. So actually is the basic idea of XNOR is uh, bring the floating point into the binary system. Through the XNOR, we can do convolution not in floating point but in binary. Here is our problem statement: to develop high speed of the object detecting in the real-time application. And the second one is to implement the high precision and accurate object detection on NVIDIA Jetson TX1. So we are using NVIDIA Jetson TX1 as our computer, and then to apply the object detection method into the Barelang humanoid robot vision system. So our robot depend on this method to detect ball and goal pole. here is our hardware design. As we know that humanoid robot has a lot of joint. As we can see, at least 20 joint inside of humanoid robot. Here is our prototype design, that mechanical. As you can see, the height is about 67 centimeter, and the width is about 27 centimeter. And this hardware design inside of this robot. So for vision, we use a regular webcam camera, and it's send the data into the NVIDIA Jetson 1. So actually NVIDIA Jetson 1 is just use special purpose for doing calculation object detection inside, nothing else. And then after do calculation and detecting, uh, the Jetson TX1 send the position and classes through Ethernet to Intel and UC. Intel and UC actually is also small computer that made by Intel. Here is a whole strategy of our robot inside. So for kicking, playing, and everything is programmed inside of Intel and UC. So we'll make it clear. NVIDIA Jetson TX1 is only for compute deep learning object detection and send the data of coordinate and classes to Intel and UC. Intel and UC did a whole strategy for kicking, for running, for obeying the referee, and everything inside here. And then interface board is actually to communicate with a user, or here is a human, to stop, start, and to do strategy. So human give the signal, or give the signal through this interface board. So actually this one is through the serial communication. And then from Intel and UC we have a kinematic inside. Yeah, we use kinematic to make it our robot move to a servo controller. After servo control translate the value of kinematic into movement by sending the data to a servo motor. Here is our design, and here is our XNOR-YOLO method. Firstly, actually is quite similar with regular deep learning object detection. However, for the convolution we use the XNOR bit count layer. So for the input, actually input is from the camera. Actually is the image inside. We do convolution layer and we do max pool layer, and here is the difference. The difference is we use not a floating point convolution, but use a XNOR bit count layer here. And then we did a max pool layer, and then here is actually a lot of convolution XNOR bit count here. As we can see, is here is 1, 2, 3, 4, 5, 6. It has 6 layer here, and then we do root, upsample, and YOLO, and output as classes and the coordinate here. As we can see, the result of compiling is like this. We can see the The image firstly is 44x times 44x, and until is detected. Here is our experimental result. Before I show the video, I will explain. This one is a result of detecting goal pole and is detecting ball as well. However, for this fight is also detecting goal pole with a uh, low light condition, and this one is detecting ball, um, but surrounding of this area is white, as you can see. This one is pole, and the ball also white. Usually is this one if also complicated if we use the conventional method. As we can see, this one is the speed of detecting. Here we got 30 fps, and as we can see, we can detect quite well here. Ball detected, pole also detected, even though the surrounding area also white. The ball is consists of white um, color, also pole also white color. Okay, here is the experimental result video. As we can see, here is detecting the ball. Now ball is moving, and the still can manage the detecting system ball even though it's moving on, or here this is the normal light. Before is the low light, and is the ball is still detected very well. And this one is goal pole detecting. In the real time is we can see the camera or the robot is moving, even though Seki still can catch up the goal pole, even though there is not a steady. It's moving forward, backward, and it's not a steady position. This one is with a low light. It still can detect the pole even though it's in the low light. Here we try to measure the length of detecting system. Here as you can see 45 centimeter, and the result is still detecting. And this the robot screen view. As we can see, we can detect the area, and this the detecting during the robot moving. So as we can see, the image is shaky. Actually it because the robot still moving, move forward, and it's detected ball, and then the robot tried to kick it, and then ball already moving forward after kick it, and it's try to search again, or to get the ball to make a goal inside the pole area. Yes, here is our experimental result, and now coming to the conclusion and future work. First is the combination of XNOR-net and YOLO method has been chosen as the object detection and enhancement. Of course, yes, the big problem of the YOLO or deep learning is cost computing is very huge. And then from the experimental result, the proposed method able to detect ball and goal pole precisely, even though the object place is different circumstance or is different position, condition, perception, many things. And also when it's compared to the last method detecting object, this method generate quite accurate and faster than before. In the future, we will improve the localization of the robot based on the result of the object detection, so that the robot able to understand the opponent, opponent, and then teammate. So we could understand whether the robot is teammate or the opponent. So we can give a pass or do avoid if the facing the other robot. That is end of our presentation about the XNOR neural network. Thank you very much for your time.